Hello everyone, welcome to Makoma Mlemo Science Hub. This is Makoma, and in today's video we'll be looking at representing redox reactions. So redox reaction can be shown in two half reactions, showing the transfer of electrons. So what do we mean when we talk of half reaction? So you're going to have an oxidation half reaction and a reduction half reaction. So what we're basically trying to say when we say oxidation half reaction is that you'll have a full reaction given to you, and in that full reaction you'll just look at the atom which is undergoing oxidation, and you just write the part of the reaction which focuses on oxidation. Same applies to reduction. You just take the part of the reaction which focuses on reduction. Hopefully you get what I'm saying, guys. Ne? So over here you have a format of how an oxidation half reaction will look like. So we have atom X changes to X2 plus. Okay, so for now I don't want us to mind the two electrons. Now I want to show you how they got that two electron. So now you can see, okay, it went from X. Here in X, remember, is this a pure element, so the oxidation number is 0, and here the oxidation number is 2 plus. We can see that the oxidation number has increased, which means this is oxidation. Okay, it has lost electrons. But then now, why over here do we have two electrons? How did they get that two electrons? So the one thing that you must know whenever you write half reaction is, let it be oxidation half reaction or reduction half reaction, is that the charge must balanced. Okay, so when I say charge must balance, it means the charge in both sides must be equal. Okay, so now the charge over here in this side, you can see the charge is 2 plus, this side charge is 0. So how are we going to change the charge? Like, what are we supposed to do to make sure that the charge is equal on both sides? So you can see, okay, if you were to add 2 electrons this side, your charge will be balanced. So this is how this is where the two electrons comes from. And guys, please note that the electrons are shown as products in oxidation half reaction, because oxidation is loss of electrons, so it's more like the electrons are being released. That is why we have the electrons in the product. Hopefully you're still with me up to so far, guys. Right now I want us to look at the reduction half reaction. Okay, so over here is how your reduction half reaction is supposed to look like. So you start with this certain ion Y2 plus, and over here it ends as Y. For the moment, don't mind the plus 2 electrons. Okay, so now you can see now see that, okay, charge on this side is 2 plus and charge on this side is 0, because the oxidation number over here is 0. So how are we going to make sure that the charge are equal? So you can see, okay, you can add 2 electrons to this side to make sure that the charges are equal. Okay, hopefully guys you get what I'm saying now. Remember that whenever you write the oxidation and reduction half reaction, your charge must always balance. Okay, then now I want us to look at this thing called the net ionic reaction. So when you talk of the net ionic reaction, you are going to combine your oxidation half reaction and your reduction half reaction. So in order for you to write this, you can see, if you look at the net ionic reaction, the two electrons here are not there. What happens to the electron? Where did they go? Because you can see I've already mentioned that you're going to combine those half reaction. But someone is wondering, where are the electrons? Because the electrons are here, but in the net ionic reaction the electrons are not there. So what happened to the electrons is that the electrons has cancelled each other out. You can see they are equal. So whenever you write the net ionic reaction, you must make sure that the electrons are equal. So in this case, your net ionic reaction, because the electrons have cancelled out, basically you're taking the reactants for your oxidation half reaction, that is X, and for your reduction half reaction, that is Y2 plus, and this will give you the products of your oxidation half reaction, which is X2 plus the product of your reduction half reaction, which is Y. Okay guys, that will be all for today from me to you. Thank you for watching guys. Please don't forget to like and subscribe to our YouTube channel.